Swayam Prabha. Digital India. Educated India.
Welcome back. Let us continue with the same topic, storage design requirement, in the lecture number 20, part 2. Let us see the difference between a cold room and a cold store. So, if you take a cold room, normally a cold room is a single room. It is a single room with height not exceeding any room with height not more than 10 feet or equivalent to 3 meter. So, it is considered as a cold room. Here mostly the products are handled, the commodities or the products are handled manually, that is without the usage of mechanical equipment. Because the stacking system or the racks where the products are stored, it is easily accessible by the workers or the laborers without the usage of the mechanical device, any mechanical device. If you take a cold store, it could be single or a multi-room facility with different products at different temperature in different rooms. Okay, so this is very, very important. Different products. Let me change the color. So different products at different temperature in different rooms. Normally, this multi-room facility, the cold room, okay, it is not used for products of single type. When we have multiple products whose storage temperature varies, whose not only the storage temperature, the humidity, the RH value varies. When there is change in these properties, like especially the different temperature and different humidity, so we have to use the cold store. We have to use the cold store, not a cold room. Coming to the height could be a single or multi-story one. As I said, normally in a single cold room, the height not exceed 10 feet or 3 meters. However, in case of multi-storied cold rooms, the height may not be limited to 10 feet. Height could be a single or multi-story requiring forklift for loading and unloading the product. Mostly in cold room, the manual type of loading is used, whereas in cold store, where multi-story infrastructure facility is there, the mechanical devices are used for loading and unloading. So this is the photograph of a single cold room. Here you can see, looking at the picture, the commodity or the product which is stored, it is of same kind. If you want to store a particular single product, it is recommended to use a cold room instead of a cold store. When we have different commodities at different storage temperature, even the relative humidity are also differs from one product to another product, then multiple rooms would be required. It could be in the same floor or in different floors. So here we can see this is the photograph of the cold store. So the inside view, the left picture on the left side is the inside view of the cold store, and the one which is on the right side, that is the external photographic view of this one. As we can see, it could be a two-storied cold store, ground floor and a first floor. And the left side picture gives a clear view of the stacking system, the pallets, the racks which are used row wise, column wise, etc. All these things are there. This is the photographic view of a cold room, that is the internal side of the cold room. When we want to design the cold room, when we want to calculate the estimate the size and the shape, so there is one factor which need to be considered, that is the aspect ratio. Aspect ratio is the ratio of surface area to floor area. For example, here I have taken a cube. Okay, the side is taken as 1 meter. The surface area, so there are 6 sides of it has 1 meter on each side. There is 6 sides. The surface area is 6 meter square. The floor area is 1 meter square. So when I divide the surface area by the floor area, I get a ratio that is called aspect ratio. Aspect ratio. So this is when we calculate the aspect ratio for this dimension, which is not a cube, this one. If you see, if the size and the dimensions are like this one, 0.5 meter, 2 meter and 1 meter, so we can easily calculate the surface area. 2 into 2 plus 1 into 1 plus 0.5 into this one. Add this one. 0.5 plus 0.5 plus 2 plus 2 plus 1 plus 1. So the surface area comes to 7 meter square. Surface area comes to 7 meter square. So this is a rectangular shape. Floor area 1 meter square. When we calculate the aspect ratio, so it comes to 7. The cold room or the cold store to be designed with least aspect ratio. This point is very, very important. The aspect ratio to be considered, it should be as small as possible. Then the insulation, it's a very, very important material which is used in the construction of the cold room. Rooms to be constructed with polyurethane foam, that is normally puff. It is in short form, it is called as puff. Puff is used, puff panel with cladding on both sides. The recommended thickness of the insulation material is 100 mm to 120 mm. However, for some cases, it can go up to 130 or 140 millimeter, and with density 40 kilogram per meter cube. Apart from puff, there are other materials also like polyiso cyanurate or expanded polystyrene. Expanded polystyrene is EPS. Expanded polystyrene. EPS. That is a short form of expanded polystyrene. And polyurethane foam is referred to as puff. Cladding material can be a stainless steel or galvanized sheet with polyester coating. The photograph shows the selected insulating material is the puff polyurethane foam, so which is used for the construction of wall. For wall, it is polyurethane foam. For floor, it is extended polystyrene, that is EPS. So this is used for wall. EPS is used, recommended for floor, and for roof, polyiso cyanurate. So this is the sample of the insulating material which is used for the construction of wall, and this is used for the construction of floor. Next one is the palletization. So it is how effectively the commodities or the products are stored and it is moved out. from the controlled environment. So that is the palletization. Different racking systems are used to store the commodities or the goods, and also after it is stored, once it has to be unloaded, unloaded with the help of either manually or mechanical device. So for this, different types of racking systems are used. To name a few: drive-in, flow, push-back, mobile rack, automated pallet, etc. These are all the different types of racking, automated pallet racking systems are used. The primary objective of this palletization is used to optimize the space, optimize the airflow, to have uniform distribution of temperature within the cold storage facility. So there should not be any uneven distribution of air or variation in the temperature of the air. Okay, assuming that if the product is a same type, so the storage condition would be the same one. I mean, it will not be a different storage condition if a single commodity of same type is used. Palletization helps to optimize the airflow, to evenly distribute the air, to have uniform temperature distribution within the cold storage facility. So this is the two photographs shows the stacking system which are used in the cold storage facility. So here you can see on the left side, the loading is done with the help of a mechanical device. In this photograph, the lighting is highlighted. This is the LED lightings. So this is the LED lightings and all. Next one is the floor heating system. The floor heating system, it is an essential component, a very important component when the cold room or the cold store is designed. It prevents the floor from freezing. There should not be any formation of ice, etc., frost having. So it prevents the floor from freezing. If there is freezing, then there are chances of the the structure getting damaged, especially when we have concrete type of floors. There are different methods employed floor heating system. Raised floor for natural ventilation, natural vent pipe, forced air circulation, pumping glycol solution through tubes, electrical resistance heating. Let us see the first one, the raised floor for natural ventilation. Photograph on the left side represents the raised floor type of floor heating system. So here we can see the floor is raised above. It is not at the ground level or the soil level. It is slightly at a higher level from the soil, so that the gases from the soil does not escape into the floor, number one. And there are air voids or vents are provided so that air can flow from in any direction. So though here it shows the air vents are shown only in one direction. So air voids are provided in different directions in this type of floor heating system, so that the air flow circulate in any direction. There will not be any flow of gases from the soil or beneath the soil into this one in this type of floor heating system. So as the name indicates, the floor is raised from the soil level. Second one is natural vent pipe. This provision is made within the concrete, like where there will be gaps, this one. So the air can flow within the concrete below the insulation. Without the airflow is without the usage of any external device, naturally. So whatever the velocity is there with which the air is flowing naturally without the help of any external device, especially a fan. In this method, PVC pipes are used through which the air is circulated with the help of a fan. Pumping glycol solution through the tubes. A secondary solution, it is a secondary fluid. Glycol is a secondary fluid. So it is pumped through the tubes. That is one method of, as the name indicate, it is one method of floor heating. And electrical resistance heating method is also there. The photograph of or the picture of the electrical resistance method, heating method is shown on the right side of this slide. So here you can see heating element is used underneath the floor or beneath the floor to heat the floor in order to prevent the formation of ice or to prevent it from freezing. So these are some of the methods of floor heating system. Next one is the vapor barrier. It is a very, very important aspect which has to be considered while designing a cold storage. So here, if you see, I have just represented a table for various temperatures, temperature 40, 5 and minus 20. 5 is the relative humidity. This is the relative humidity. The symbol which is used to represent is 5 in terms of percentage. Temperature 40, 25% relative humidity. Temperature 5, 85% humidity. Minus 20, 95% humidity. So these are all the values taken from the psychrometric chart. When the temperature of the air is 40 and relative humidity is 25, the specific humidity, this is called specific humidity. And P suffix WV is the partial pressure of the water vapor. Partial pressure of the water vapor. And this is the partial pressure of water vapor. Partial pressure of water vapor. So at 40 degrees centigrade and 25% relative humidity, the specific humidity is 0.01116 kg of moisture per kg of dry air, that is the unit, and partial pressure of water vapor in Pascal is 13.9. So as the temperature drops and the RH value increases, the specific humidity decreases from 0.0116 to 0.0046 and subsequently to 0.0006. So it is decreasing. And the partial pressure of the water vapor also decreasing. Vapor pressure, the difference in the partial pressure of the water vapor is the driving force for the moisture to enter into the cold room. Okay, so this is very important. It is the driving force for the moisture to enter the cold storage. It is directly proportional. If the difference is more, then the chances of more moisture getting into the cold room, and if the difference is less, then the amount of moisture which is entering into the cold room will be less. Moisture can penetrate through the insulation and it can condense to form ice. So what happens when we have such a situation? The effectiveness of the insulation material will be coming down, will be reduced, and it will not serve the purpose of maintaining the desired temperature. As much as possible, moisture should not enter into the cold room or cold store. So to prevent that one, a vapor barrier is used. It is a material with high resistance to moisture. It is installed on the hotter side of the insulating material. So there are normally two sides. One is the cold side and another one is the hot side. So this vapor barrier is attached with the insulating material so that it can minimize or eliminate the moisture entering into the cold room. The water vapor pressure drops below the saturation pressure, thereby prevents condensation in the cold room. So this is the principle. Methods of providing the vapor barrier. So I'll just quickly, this is more of a theory portion. Just learners need to know the methods. What is the function of the vapor barrier? Not only the vapor barrier, some of the topics which I have discussed in this lecture, especially the palletization, the vapor barrier, the type of insulation. So all these things are, the learners need to know the function of that particular material or particular component, and how does it assist the designers while designing the cold room. Plastic coating or thin fluid. Under that, asphalt, bituminous emulsion, polymer resins are used. Sealing sheet, asphalt, paper, plastic sheet, metal film, that is the aluminum foil is used. Coming to the last portion in this part 2 of the lecture number 20. What are the other important points or considerations that has to be taken into account while we are dealing with the the storage design requirements? The exterior surfaces should be of light color so that it can absorb less heat compared to a dark surface. It should be of light color. The surfaces or panels should use reflective material which has high reflectivity of light and thus minimize radiation heat gain. So, reflective material. If you don't have these, suppose if you are having the dark color or if you are not using a reflecting material of high reflectivity, so what will happen? It will add to the heat load, and the capacity of the refrigeration system also. Obviously, the capacity of the refrigeration system will increase. The east and west side should be shaded with overhangs to reduce direct solar radiation heat. Loading of the product should be done preferably at night when the ambient temperatures are low. If possible, loading and unloading area should not be in the direction of the wind. Curtains, strip curtains of 2 mm thick PVC, that is polyvinyl chloride, to be provided on the doors to reduce infiltration. Infiltration is the process during which the air, there is a leakage of air through gaps or through the gaps in the door or through the gaps if the walls are not constructed properly, if the wall contains some porous, if there is some porous nature in the wall, in the construction of the wall, there are chances that the air can leak into the cold room. So that is leakage of air through various means, that is called infiltration. Flow of material in and out of the cold room should be properly planned so that the frequency of door opening, this is very important. The opening and the closing of the door should be as minimum as possible. Otherwise, it will add up to the heat load. And the duration can be minimized by installing sensors. Then there should be a fire protection device. Tall trees planted on east and west side helps to provide shading. Maximum heat gain comes from concrete roof exposed to sunlight. The heat gain can be reduced if reflective tiles are used. Minimize the number of columns used in the construction of the cold room. High ceilings is recommended. Minimize flat edges and corners to reduce air turbulence. With this, I conclude the lecture number 20, part 2. Thank you.